Alright, Chapter 5 Summary. As the study of the future resistance, important points of the chapter have been summarized below. Basic transformer. The basic transformer, electrical device that transfers all the current energy with the one circuit with another circuit of the magnetic coupling of the primary secondary windings of the transformer. They accomplish for the mutual inductance. The coefficients of the coupling, or K, of the transformer is dependent on the size and the shape of the coil, with the relative position of the character for the core between the two coils. The ideal transformer is one where magnetic lines of flux produce the primary coupling and the entire secondary. The higher the coupling with the transformer, the higher the transformer energy. The voltage applied with the primary winding cut with the current to flow with the primary. The current generates the magnetic field generating the counter EMF, which opposite phase of the applied voltage of the magnetic field generated with the current in the primary with the secondary winding induces the voltage in the winding. Transformer construction. Transformer consists of the two coils insulated with wire wound core with the primary wound onto a form of the wrapped in with an insulating material such as the paper cloth and secondary winding and the wound and the top of the primary. Both windings wrapped in the insulating material. The windings are then fitted onto the core with the transformer. The core of the air shape of the material. The most common material is the air soft iron core, laminated steel. Most common type of the transformer shell core with a hollow core type. The type of the shape of the independent of the transformer. The voltage applied with the current and primary winding. Shows the lamination cardboard form, insulating paper lamination. Exciting current with the voltage applied with the primary transformer. The exciting current flows in the primary. The current cover the magnetic field is to be set with both the primary and the secondary winding. The magnet move with the flux cover the voltage due to the secondary winding current effect of the counter EMF primary. Or the phase secondary winding connect with the low with the current, causing the current to flow with the secondary magnetic field to decrease momentarily. The primary then draw with the more frequent current with the resulting restoring magnetic field of almost the magnitude of the phase of the current flowing with the secondary current depending on the phase of the voltage for the present and across the primary and direction of the winding with the secondary where around with the same direction as the primary the phase of the same that would be opposite of the primary the phase would be reversed. This is shown in the schematic of the drawing. Even the phasing dot for the dots may be leave with the primary with the secondary have the same phasing. Lacking the phase of phasing dots on the schematic means a phase reversal. Notice the turn ratio of the transformer, the ratio, the number of the turns of wire, primary winding, number of the turns, secondary winding. When the turn ratio is stated with the number of the representing the term of the primary, also stated first 1 to 2 ratio means secondary winding has twice the number of the turns of the primary. In this example, the voltage across the secondary is two times the voltage across the primary. So you have 10 volts at 1 volt and 10 volts at 2 volts with two windings. Power current transformer. Power current ratio of the transformer dependent on the factor of the delivered in the secondary is always equal to the power delivered in the primary. Prime for the loss of the transformer. This will always be true with regards to the number of the secondary windings. Using the loss of power, using the law of power and current, it can be stated that the current of the transformer and the inverse voltage return ratio of the power remaining the same loss or less, regardless of the number of the secondaries. Our transformer losses. Transformer losses have two sort of the copper loss, the magnetic loss, copper loss cover the resistance of the wire, ampere squared over the resistance, magnetic loss cover the eddy current, the hysteria, and the core of the copper loss is coefficient constant after the coil has been wound. Therefore, the measurable loss hysteria is the constant particular voltage or current is lost in constant of the particular voltage or current. Eddy current loss is however different in each of the frequency it has through the transformer. Transformer efficiency amplitude of the voltage induced for the secondary dependent on the efficiency of the transformer. The turn ratio efficiency of the transformer related in power loss winding with the core transformer. The efficiency in percent is equal to the power over the power output over the power input times 100. The perfect transformer will have an efficiency of 100%. Power transformer. A transformer with the two or more windings wound with a laminated iron core with the transformer is with a supply stepped up and stepped down value for the voltage of the various circuits of electrical equipment. Alright, black to black this is an iron core, black to black. Green to green, 63 volts as a smaller. Your center volt would be 700 volts between the center windings of the 350 volts, and your yellow 5 volts. So auto transformer. Transformer with a single winding where the entire winding can be used with the primary part of the winding. The secondary part of the winding can be used with the primary. Entire winding can be used secondary. Alright, so this is a movable tap on the secondary winding, so the increase between A and B in voltage primary, voltage secondary. Audio frequency transformer. Transformer, you the audio frequency circuit, the transform signal from one circuit to another. Radio transformer. A transformer, you the radio frequency as circuit to the transfer radio RF signals from one circuit to another. Impedance matching transformer. Transformer, you to match the impedance of the source and impedance of the load. The mathematical relationship for the number of the terms impedance with the transformer is expressed the number of primary number of turns from primary over the number of turns in secondary is equal to the square root of the impedance in the primary over the impedance in the secondary. And that completes the chapter. The rest of the chapters, I'm not going to go through the questions or the appendixes, but that was the fifth chapter to Navy Electric, fifth chapter summoned to Navy Electricity Electronics Training Series Module 2 Introduction Alternating Current and Transformer Navy Trot 14174.